This video is to go over building Java programs. Chapter 17 is about binary trees. Exercise 9 is checking whether two trees is equal. We're using the practice it website here. So it's similar to the equals functions that we've seen in other cases. I want to make sure that you understand it is not okay to use the equals method in this method. They don't specifically say it or ban it, but that would be defeating the purpose of this. They want you to check whether two trees are equal. Unfortunately, they don't give you any samples here, so I'm going to look at self-check 17.11 just so I can visualize this. So imagine this node were not here, okay? So we just have this tree and this tree that we want to compare to see whether they're equal. Let's take a look at some of the details here. Just like all the other problems in the chapter, this is going to be a member function. So normally it would not take a parameter, but in this case we're actually comparing two trees, so it takes one parameter. But you're going to need a new helper function that takes two parameters so that you can recurse down these two trees, which again would start here and here. So just like a lot of the other functions, we need to figure out what our base case is and our recursive case. So let's start by putting that pseudocode in here. And just like before, we're going to consider the case where we're looking at null, and then otherwise we're going to look at recursive case. So in the base case of null, let's take a look at the tree again. So that would be, so we're going to start here, and then we're going to recurse, and we're going to go down to here and here, and then we're going to recurse, and we'll be going down to here, this node off here, and this node off here. Those are both null. So in the recursive case of one tree being null, remember we've got the this tree, and then we've also got the passed in tree. So in the case where we've got null, we need to check that the other one is null, right? That's because if let's see, where's an example of that? So if we go down to this subnode here, these 4s, when we go down here, this one's null, but this one is not null. So we would immediately return that this is not equal. Okay, so that's the first thing we need to check. We need to check whether if it's null, is the other one null? So we could put okay, so that's one potential base case. There are a couple of other base cases too. So there's the base case where they're both null. If they're both null, which would be the case here and here, then it's true. If only one of them is null, then we're going to return false. So we need to deal with a couple of different null cases here. If null, I'll check if the other's the same. Yeah, that pretty much covers that. Now for the recursive case, what are we going to have to do? So in this example here of passing in these two nodes, we're not dealing with null. So we have data in here and we have data in here. So we first want to check whether the data in these two nodes is the same. Assuming they are, then we want to recurse and check to see is the data the same on the left and is the data the same on the right. So let's write that down. If the data is same in T1 and T2, then recurse on T1 and T2. And when I say recurse on it, we do need to return something, right? We have to return whether that is true. Both it's true on the left and true on the right. And there's a very compact way you can do that. It shouldn't take very much code at all. So another interesting thing about this problem is that the practice it is not very good at testing your code, because they do give you a test case where both the trees are null, but what they should also be doing is testing to see if either of the two trees is null, because you could have a case where T1 is not null but T2 is, or T1 is null and T2 isn't. Both of them are null, because if you start trying to grab the data out of T1 or T2 and it's null, then you're going to crash. So you really actually have to check several different cases here. you got to check all the potential null cases before you access the data in T1 or T2. Otherwise, it's going to crash. Practice it won't detect it, but you need to be careful and make sure that your code works, because otherwise, when you go out and do it for some other reason, it's going to crash. And that's pretty much it. So let's review what we've learned in this problem. I'm going to switch back to this diagram again. So just like in all the other cases, we're recursing. We're going to eventually get to nulls. In this particular problem, dealing with nulls is a bit of a challenge, because if you don't check for null, you've got two trees, first of all, and you've got to check the nulls. There's like 4 different combinations for whether it's null or not. If you don't check for all the null combinations, you can crash when you start to access the data. Like here, there's data here and there's data here. But in this case here, there's no data here and there's data here, down here. So if you start to try to access the data for T2, well, you're going to crash. So you've got to be more careful there. It's also interesting because we are finally taking an actual parameter, which is another tree, and that's fairly common in binary tree operations. And that also, raises that same question I just mentioned about is one of the trees null. You got to make sure that none of the trees are null before you start accessing them. So you should be able to write the code from that. And again, just because Practice It accepts it, don't assume that that is correct. You got to make sure that you've handled all of the different null cases. So if you found this video useful, please like and subscribe.